Alright, today's notes are going to be on the properties of radicals. First off, a radical expression is an expression that contains a radical. Remember, a radical is a symbol that looks like that. Alright, so a radical is in simplest form if no radicands. Side note, a radicand is the quantity under a radical symbol. So when no radicands have a perfect nth power as factors other than 1. So there can't be 4, 9, 16, any of our perfect squares under the radical symbol. Radicands also can't contain fractions, and they can't be in the denominator of a fraction. They can be in the numerator. All right, so the core concept for today is that if you have the square root of two numbers multiplying by each other, the square root of a times b, it's equal to the square root of a times the square root of b, if a and b are both greater than or equal to 0. So they showed that with numbers. The square root of 9 times 5 is equal to the square root of 9 times the square root of 5, which is helpful to us because we know that 3 is the square root of 9. All right, so using that core concept on the first page of our notes, we're going to simplify each of these expressions. So the square root of 24, we're going to break down into the square root of 4 times the square root of 6, because 4 times 6 equals 24, and I know that 4 is a perfect square. So the square root of 4 is 2. So the square root of 24 is equal to 2 times the square root of 6. All right, and 6 does not have factors that are perfect squares, so that's as simplified as it can go. All right, so part B adds a negative to the mix. When there's a negative, you have to keep that negative out front. So we're going to rewrite this as the negative square root of 16 times the square root of 5. Since 16 times 5 is 80, and I know that 16 is a perfect square. And since 16 is a perfect square, I can simplify that part, make it 4, keep the negative out front, and now I have negative 4 times the square root of 5. Part C adds some variables to the mix. The square root of 49x cubed can be written as the square root of 49 times the square root of x cubed. Now we know the square root of 49 is 7, so I can go ahead and simplify that right away to 7 times the square root of x cubed. Now variables we can break up the same way. So x cubed is the same thing as, the square root of x cubed is the same thing as the square root of x squared times the square root of x. So then when I simplify that, I take the square root of x squared, which is x, and I still have the square root of 1x, or x to the power of 1, under the square root sign. And that's our final answer, 7x square root of x. All right, the variable in part D has a larger exponent, but we're actually going to break it up the same way. So we'll take care of the numbers. Square root of 75, we're going to break into the square root of 25 times the square root of 3. And then the square root of n to the power of 5, we're going to break up into as many n squareds as possible. So the square root of n squared times the square root of n squared times the square root of n to the power of 1. Now notice the numbers, the exponents, add up to 5. So 2, 2, 1, that equals 5. All right, now we're going to simplify that expression. So square root of 25 is 5. I can't simplify square root of 3 any further, so we're going to leave that as square root of 3. The square root of n squared is n, square root of n squared is n, and we have to leave the square root of n. Now, this is not the right way that it should be written. We're going to combine the stuff left under the radicals. So we're going to combine the radicands into one radical again. So our final answer is going to be 5n squared times the square root of 3n. Notice I also combined the two n's and the 5 to be 5n squared. All right, so just like we can break up the factors of radicals or radicands, we can also break up the quotients. So if I have the square root of 3/4, I can break it up to the square root of 3 over the square root of 4, which I can then simplify to the square root of 3 over 2. Leaving it as the square root of 3/4 is not simplest form. All right, so we have the square root of 15 over 64. We're asked to simplify it. We're first going to simplify this to the square root of 15 over the square root of 64. Now, 64 is a perfect square. Its perfect square, its square root is 8. So we're going to make this the square root of 15 over 8. And I can't simplify the square root of 15 anymore either. So that is our final answer. And b, square root of 81 over x squared, we're going to break into the square root of 81 over the square root of x squared, both of which are perfect squares. So I have 9 over x as my final answer. And C, D, and E here are just a continuation of the last example. The negative square root of 17 over 100, we're going to break into negative square root of 17 over the square root of 100. And 100 is again a perfect square, so I can keep this as negative square root of 17 over 10. All right, D, square root of 36 over z squared, we're going to break into the square root of 36 over the square root of z squared, both of which are perfect squares. Square root of 36 is 6, square root of z squared is z. Now this last one gets just a little more complicated. The square root of 4x squared is on top, the square root of 64 is on bottom. The square root of 4x squared, we have to think of both the square root of 4 and the square root of x squared. So that's going to be 2x, and then the square root of 64 is 8. Now we want the fraction in its simplest form. So 2 over 8, both of those numbers are even. I know I can simplify that fraction one more step so that I have 1x, or just x, over 4. All right, so our next step is going to be rationalizing the denominator, which means to eliminate a radical from the denominator by multiplying it by an appropriate form of 1. So just like when we simplify fractions, so if I have this fraction 16 over 20, both of them are divisible by 4, so I'm going to divide it by 4 over 4, which is 1. Anything divided by itself is 1. So I can divide by 1 and still have the same fraction. 16 divided by 4 is 4. 20 divided by 4 is 5. So 16/20ths is equal to 4/5. And then quick review on equivalent fractions. If I have the fraction 2/5, I can multiply that by 3 over 3, which is still 1. So I'm just multiplying by 1. 2 times 3 is 6. 5 times 3 is 15. So 2/5 is equal to 6/15. All right, so we're going to use that concept to make sure that there are no radicals in the denominator. We're going to rationalize the denominator. So 1 over the square root of 5, to rationalize that, we're going to multiply it by the square root of 5 over the square root of 5. Because the square root of 5 times the square root of 5, they're going to cancel each other out. So now when we multiply straight across, we have the square root of 5 over 5. Square root of 5 times square root of 5 is 5. All right, example B, the square root of 10 over the square root of 3. To rationalize that, we're going to take the radical in the denominator, so square root of 3, put it over itself, so we're just multiplying by 1. And then we have the square root of 10 times the square root of 3 on top, and then the square root of 3 times the square root of 3 is just going to become 3 on bottom. Now I can simplify this one step further, just like I did when I was trying to simplify backwards. Now it's like I'm going backwards. So 10 times 3 is 30. We're going to have the square root of 30 on top and 3 on bottom. That is in simplest form. All right, so now there's a variable in the radicand. That's okay. We're going to do it the same way. We're going to multiply by the square root of 2x over the square root of 2x. And now we're going to have 7 square root of 2x over 2x. All right, and D through F here are just a continuation of the last page, so we are rationalizing the fraction, or the denominator. So we're going to multiply by the square root that's on the bottom. So square root of 3n over square root of 3n. And this becomes the square root of 15n over 3n. All right, now we have a fraction under the radical. So first we're going to simplify that to the square root of 2y squared over the square root of 3. And now I need to rationalize that denominator. So I need to multiply by the square root of 3 over the square root of 3. So this becomes the square root of 6y squared over 3. And I can actually simplify that one step further. Notice, and some of you probably already caught this, there's a y squared in the radicand. So I can take that y out because I know the square root of y squared is y. And then I have y square root of 6 over 3. That's our final answer. All right, and last one, square root of 144 over 13. We are going to change that to the square root of 144 over the square root of 13. And I know what the square root of 144 is. It's 12. I'm going to simplify that before I try to rationalize it. I don't want to multiply 144 times 13. All right, so now I'm going to try to rationalize it by the square root of 13 over the square root of 13. So I'm going to end up with 12 times the square root of 13 over 13. Final answer. All right, example 6, problem solving. So the distance d in miles that you can see to the horizon with your eye level, h feet above water, is given by this formula. How far can you see when your eye level is 5 feet above the water? Well, h represented feet, so we're going to plug in 5 for h. We're going to rewrite this as d equals the square root of 3, that's where I'm plugging in 5, over 2. And now I want to simplify this. So this is all equal to the square root of 15 over the square root of 2. But to simplify it, I can't have that square root on the bottom. So I'm going to take the square root of 15 over the square root of 2, and I'm going to multiply it by the square root of 2 over the square root of 2. And we're going to end up with the square root of 30 over 2. And that's in miles. Square root of 30 over 2 miles. All right, so we have some more vocabulary. Like radicals, and think of the word like as how we used it in like terms, are radicals with the same index and radical. And remember, index is like n in the nth root, or we had it written like that. All right, so to simplify each expression, I notice that I have 2 square roots of 7 with different numbers in front, but that's okay. I can combine those. So 5 square root of 7 minus 8 square roots of 7, it's going to equal negative 3 square roots of 7. So that whole expression is going to be equal to the square root of 11 minus 3 square roots of 7. All right, and the second one I need to simplify first. The square root of 20 is equal to the square root of 4 times the square root of 5. And the square root of 4 is 2, so that's equal to 2 square roots of 5. So I'm going to rewrite this expression as 10 square roots of 5, but instead of square root 20, I'm going to say 2 square roots of 5. So then I can combine those two to get 12 square roots of 5. All right, example 9. We are going to simplify each expression. So to simplify, when there's a number outside parentheses, we're still going to distribute just like we would if they were not radicals. So now we have the square root of 5 times the square root of 3 minus the square root of 5 times the square root of 75. All right, so first I'm going to combine the square root of 5 times the square root of 3 to become the square root of 15. And now I know 5 goes into 75, so I'm actually going to split the square root of 75 to the square root of 5 times the square root of 15, just so that I can combine those square roots of 5. So now I have the square root of 15 minus 5 times the square root of 15. And now those are actually like radicals. I have 1 square root of 15 minus 5 square roots of 15. So my final answer is going to be -4 square root of 15. All right, in the second example, we're going to start the same way. So we're going to multiply that square root of 3 by both of those. So now I have 8 square root of 3 times square root of 2 plus 7 square root of 32 times square root of 3. All right, so now we're going to combine those radicals. So square root of 3 times square root of 2 becomes of 6. And then square root of 32 times square root of 3 becomes square root of 96. And now we're probably combining like radicals. So I'm going to check to see if 6 goes into 96, which it does, by 16. So now we have 8 square root of 6 plus 7, and I'm going to break that 96 into the square root of 16 and the square root of 6. And now 16 is actually a perfect square, so I can simplify that more before combining like radicals. I still have 8 square root of 6, and now I have 7 times 4, so this is going to become 28 square root of 6, and now I can add them together. 8 plus 28 is 36 square roots of 6. 2 times the square root of 5 minus 4 squared. So I think this is going to be easiest to see if we write it out as 2 binomials and then we FOIL it. If I take the first terms, that's 2 square root of 5 times 2 square root of 5 times 2 square root of 5. 2 times 2 is 4. Square root of 5 times square root of 5 is 5. 4 times 5 is 20. All right, my outside terms are 2 square root of 5 times -4, which is going to be -8 square root of 5. And my inside terms are -4 times 2 square root of 5, which is going to be -8 square root of 5. And my last terms are -4 times -4, which is positive 16. So after I FOIL it, I have to add all of those together. So I have 20 minus 8 square root of 5 minus 8 square root of 5 plus 16. Combine like terms here. 20 plus 16 is 36. -8 square root of 5 minus 8 square root of 5 is -16 square roots of 5. All right, we had a lot of new information today. We learned what a radical expression is. That is an expression with a radical. We learned how to simplify radical expressions when there's a perfect square in the quantity under it. We learned what a radicand is. A radicand is the quantity under a radical expression. How do you rationalize the denominator? Well, you multiply it by something that's equal to 1. So if you have square root of 3 on the bottom of a number, you're going to multiply it by square root of 3 over square root of 3, because that is equal to 1. All right, what are like radicals? They're radicals with the same index and the same radicand. So I could add 2 square root of 3 plus 4 square root of 3, because those are like radicals. And we also learned how to simplify expressions with more than one like term.